Hi all. In this session we are going to learn about scope in programming languages. We are going to learn about what are the different types of scoping like static scoping and dynamic scoping, and how a program execution will take place inside a programming environment, and what are the various activities that will take place during a program execution in the program referencing environment. First, let's learn what is scope. Scope is the textual region of the program in which a binding is active. Binding is simply an association between a name and an object. In most modern programming language, scope is determined statically. That means scope is determined during the compilation time. Typically, a scope is the body of a module or a function or a subroutine, class, or even structured control flow statement, sometimes called as a block. At any given point in a program's execution, the set of active bindings is called as current referencing environment. So let's understand all this concept with a case study. Consider the program to swap two numbers using function. As we all know that the program will execute from the main function, and in the main function we are declaring two variables as integer type n1 equal to 10, n2 equal to 20, and we are calling the function swap of n1 n2. That means we are passing the values 10 and 20 as the arguments to the function swap. So this 10 and 20 are received by the swap function, and the n1 in the swap module will get 10 and n2 in the swap module will get 20, and we are declaring another variable temp, and we are doing the swap process. And after the returning from the sub function to the main function, we are printing the value. But let's understand how this program execution takes place inside the program execution environment. So as we all know that the program execution starts from the main function. So whenever a function is initiated, a stack frame or an activation record is created in the program referencing environment. So consider this rectangular block as the stack frame or the activation record for the main function. So what all memories we are creating will inside this particular function will be stored inside this stack frame of main function. So the first we are declaring int n1 equal to 10. So in the main stack frame it will create a 4 byte memory and it will be named as n1, and we are copying the value or initializing the value as 10. And the next statement in the main function is int n2 equal to 20. So again a 4 byte memory is reserved for an integer variable, and it is mapped with the name n2 or binded with the name n2, and the value 20 is binded with the variable name n2. Next we are going to call a swap function, swap of n1 comma n2, that means swap of 10 comma 20. So we are again calling a function. So whenever a function is called, a new stack frame is created. So on the top of the stack a new stack frame is created and it is named as swap, and whenever a stack frame is created, a static link is created from the new stack frame to the stack frame from which the function is called. So the swap function is created from the main function, so a static link is created between the swap and main function. Whenever the swap function is executed or the lifetime of the swap function is completed, then the control is transferred back to the main function. So a static link is created at the point of calling a function. So the control is transferred to the swap function. So inside the swap function we are creating two memory blocks named as n1 and n2. This n1 and n2 are different from the n1 and n2 that we created in the main function, because the current referencing environment or the current frame pointer is points to the swap function. So the active region is now this swap activation record. So inside this swap activation record we are creating n1 and it is 10, n2 and the value 20 is copied to n2. After that we are declaring a variable int temp. So the frame pointer is pointing to the swap function. So the current active region is this swap module. So the temp will be stored in the swap activation record. So temp is declared and the memory space is allocated. Then we are doing the swap procedure. Temp is equal to n1. That means the value of n1, which is 10, is copied to temp location. So now n1 is having the value 10, n2 is having the value 20, and temp is having the value 10. The next statement is n1 equal to n2. That means the value in n2 is copied to n1. The value in n2 is 20, so this 20 will be copied to n1 in the next step. So now in the swap activation record, n1 is possessing the value 20, n2 is possessing the value 20, and temp is possessing the value 10. And the next step in the swap function is n2 is equal to temp. That means the value 10 is copied to n2. So that change is done. Value of temp, which is 10, is copied to n2. Now the values are actually swapped and the end of the swap function. So whenever a subfunction call is end, the static link will be destroyed and the stack frame will be deleted. So after execution of this closing bracket, the compiler will clear the currently active region and the control is given back to the main function. So in the main function, we have the old n1 and n2, and if we are executing the next statement, printf after swapping n1 is equal to %d, n2 is equal to %d, comma n1 comma n2. So the values in n1 is 10 and n2 is 20. That means actually in effect we didn't do any swapping. How this is happened? Because all the swapping activities are taking place in the swap activation record, or the n1 and n2 that we are creating in the swap function. So whenever we are calling a function by passing arguments executed using call by value method, then the copy of the actual arguments will be given to the subfunction. So all the swapping activities and operations are performed only in this swap function. Whenever the swap function is completed, the control is given back to the main function. In main function, these operations are not in effect. So this is what is happening when we are doing function calls. So the output of this program will be the same output as that of n1 and n2 in the initial step itself. The output will be 10 and the output will be 20, because in the main function there is no change or no effect in n1 and n2, because all the operations are performed in the swap function. So the scope of n1 and n2 will be entire time of this execution, that is entire time of both the main function and swap function, and the scope of n1, n2 and temp is only during the execution of this swap function. After the execution of this swap function, the active region will be deleted or the activation record will be deleted. So the scope of n1, n2 and temp will be only during the execution time of swap function, and the active region of n1 and n2 that is declared in the main function will be till the entire lifetime or entire execution time of the program. So I hope now you understand the concept of scope of a variable or scoping in programming languages. Thank you.